Hi everyone, welcome back to Chem Help ASAP. Today we are going to be constructing our orbital energy diagram. Now this will help us connect our quantum numbers to where the electron actually is in the atom. It will also help us understand the order that we fill the orbitals. So let's start working. Okay, to start building our energy diagram, we're going to go back and talk about our quantum numbers. So if you remember, n is the principal quantum number, and it tells us the size and the energy of our orbitals. So for example, if we're talking about the s orbital, you remember that the s orbital is a sphere. Now, if we start comparing the 1s orbital to the 2s orbital to the 3s orbital, what we end up seeing is this diagram right here, which looks kind of like a bullseye. So this small circle in here is our 1s orbital. It is the smallest, it is the lowest in energy. Once we move up to our 2s orbital, the orbital is much larger and it also has a higher energy, etc., etc. Here is our 3s orbital, and of course you could continue this up all the way through the 7s orbital. Okay, so we know that as n increases, our size and our energy increases. But let's review again our L and our m sub L. When our value of L is 1, you'll remember we have 3 values of m sub L, and that corresponds to our 3p orbitals. Now, there is something special about these 3p orbitals, especially when we're talking about energy, is they are called degenerate orbitals. And degenerate orbitals have the same energy level. So px, py, and pz all have the same energy. Now remember, these can have different values of n. So you have your 2p orbitals, your 3p orbitals, your 4p orbitals, etc., etc. However, all of the 3p orbitals have the same energy. This applies also to the d and the f orbitals. So remember, d orbitals have 5 values of ml, f orbitals have 7 values of ml. And again, if you're looking at the picture here, these are all degenerate orbitals. Again, with the F's, these are 7 degenerate orbitals. They all have the same energy. Okay, let's start putting this together in an energy diagram. Okay, we're going to start our energy diagram with our smallest and our lowest energy orbital. This is n equals 1. Now at n equals 1, there's only one orbital. It is the 1s orbital. So you can see I have put my 1s orbital at the very bottom of my energy diagram. Next, we go to n equals 2. In the n equals 2 shell, we have our 2s orbital and our 2p orbital. Now this is where it's really important that we understand that the 2p orbital is degenerate. So you can see I have put 3 spaces here, and you could call these 2px, 2py, and 2pz. They are 3 orbitals, but they're degenerate. They all have the same energy level, so you can see I have put the lines at the same energy level. Okay, next we go to our n equals 3. There we find the 3s orbital and the 3p orbital. Again, I didn't specify this, but we could call this 3px, 3py, and 3pz. Just like our p orbitals are degenerate, you can see as we move up this energy diagram, here I have the 3d orbitals. These are also degenerate, but notice I put 5 spaces. Here are my 4d orbitals. Now this diagram can continue up, but it gets quite large. If you continue this up to include the f's, you would have 7 spaces for the degenerate f orbitals. Okay, we are going to work with this energy diagram. We are only going to go up to the 6s orbital because it starts to get large and rather cumbersome after a while.
Now that we have our orbital energy diagram, it is time to start putting electrons in. So join me for our next video where we will put electrons in their place.